Hi, and welcome to the video where I would like to show you how to easily motorize any of your DIY devices, home appliances or toys, and control them using Bluetooth in your mobile phone. This will require some basic electronic and programming skills, which I think anyone can learn at such level. The project will be cut in two parts. In this video I will show you the electrical schematic, along with the programming part, explain some stuff necessary to understand everything clearly, for example BLE communication, and assemble the circuit and the breadboard where you will be able to test the functionality using a smartphone. In the next video I will explain how we can move from the breadboard to the actual device that can be used in your projects. We will discuss whether to build such circuit on a universal board or to order your own PCB. We will use some 3D printing to build a nice case for the board, and I will also explain how you can create your own mobile application that can be used to control any Bluetooth devices. So let's get started! Okay, so here we have the schematic of the full circuit, and let's start with power supply. As you can see, here we have the LiPo battery, and the labels doesn't matter because we need to select such battery that will act as a power supply for both the servo and the motor. And if you can find such power supply, it's even better for you because you do not need to use voltage regulator. But in my case, I have the servo that needs 4 to 6 volts. And I cannot use 3.7 volt battery because the voltage is too low. And I cannot directly use 7.4 battery voltage because, well, the voltage is too high. So I chose to use the more powerful battery, but with voltage regulator that will output the 5 volt, and then I can connect the power of the servo to this 5 volts. And one more thing when it comes to power supply, we have the small ceramic capacitor in here just to filter any noise that can occur in the circuit. Now let's investigate other connections. Starting with servo, we have only 3 pins, 2 of them are power supply, so the third one is used to control the device, and we connect it straight to the ESP32. I've chose GPIO 13, but it doesn't really matter. You can choose any other that allows for pulse modulation, and if you don't know which one is this, you need to search in documentation for PWM pins. We also want to control speed and the direction of the motor, so we will be using a motor driver, in this case DRV8833, but you can choose any other that will work for you. Just make sure to read the documentation and check the proper connections, because in this case we use only 2 inputs to control both the speed and the direction, but in some motor drivers you have the third pin, which is solely responsible for controlling the speed of the motor, the PWM. But in this case, when we set first pin to the 0 and second to 1, we have motor spinning in one direction, and when we reverse this connection, the motor is spinning the other direction. And we also want to set the PWM value for the proper pin to control the speed of the motor. And before we go to the coding part, I would like to introduce you a little bit the BLE standard. BLE stands for Bluetooth Low Energy and was developed in 2010 as a lighter version of standard Bluetooth. It is perfect for IoT market and generally for all the devices that are battery powered because it doesn't drain the battery as much as the standard Bluetooth did. And first of all, we can distinguish 2 types of devices that take part in BLE communication. First one is peripheral and second one is central. And we can think of peripheral as the less loaded device. So, for example, imagine the home automation system where you have some smart temperature sensors, for example, in one room, and you want to control the temperature of the room by using the information from this temperature sensor. So the peripheral can send periodic notifications to the central about the temperature in this room, and this way the home automation system can use this information and, for example, increase or decrease the temperature in this room. But central device can also start the communication. For example, let's say that we want to know the temperature in the room at that very moment. So the central device can send a request to the peripheral, in our case the temperature sensor, and the peripheral will send a response back with the data that we want to obtain. So in this case, the temperature in the room. Central device can send also a command, which is really similar to the request, but we don't want any response from the peripheral. So for example, in our case, the command will be sent from the mobile phone to the ESP32, that, for example, sets the value of our servo to some specific angle. And we don't want any response from the ESP32, we just want to set the servo to the specified position. And one more thing that I should have mentioned at the beginning is that the peripheral is the device that is advertising its existence in the world. So basically it's saying, I am here, if you want to, you can connect and we can exchange some data. So when a peripheral is advertising, you can go to, in your mobile phone, to the Bluetooth options, and there you have the list of nearby Bluetooth devices. And then you can see, you should see the name of this peripheral that is advertising its existence in there. And from that you can either connect or just read some basic informations about this peripheral that are included in the advertising package. So for example, its name. And one last thing I wanted to mention is how data is arranged in BLE device. So there is a concept of services and characteristics. And characteristic is the smallest unit of data, and it is categorized in different services. So imagine, for example, a smartwatch, which is a BLE device, and it has some data, it gathers some data, and it can have multiple services. And one service can be, for example, for our health monitor. So it will contain data connected to this category. And the characteristic in the health monitor service can have, for example, data about our heart rate. And the second characteristic in this service will have data about our blood saturation. And the next service will have the data about our sleep. So the first characteristic will contain how much we slept, and so on and so on. That's everything you need to know about BLE in this project to follow along. Now let's go to the coding part. Okay, so when it comes to programming part, I will be using Visual Studio Code along with Platform IO extension, which is an alternative for Arduino IDE, and I also recommend you to use it, or at least try it out, because it is also easy to use and it has much more capabilities than the standard Arduino IDE. And to install it, you can just go to the extension tab, find the Platform IO IDE, and click it. And then you just have to go to this icon, this little alien, and click open. Now you have the full interface of the Platform IO. And generally what you want to do is to create a new project. For this you can choose any board you want. For example, let's say something with ESP32. This one, you can choose framework, either Arduino or Espressif when it comes to ESP32, and just click finish. It will take some time to configure the project, to create a config file, but actually you don't need to change anything there. It will work as it is. You can also add the libraries to your project, and we will be using, for example, ESP32 Servo library. So you can search for this. This is the first one. Just click it when you have a configured project. Click add to the project and select the project that you want to add this library to. And that's actually all. You have also some other options. I will not go through this. If you want to check it out, go to Platform IO website or install it and do it yourself. So let's start with the coding. I will guide you through the code and explain everything, but it is not really complicated. So I guess if you have some basic programming background, there won't be any problems with that. So starting with these three includes, two of them are responsible for BLE functionality, and they are already in the ESP32 base library, so we need to just include those header files. And this one is from the ESP32 Servo library, so first you need to install the library and then include the header file. Next we have 6 variables that are used in the code, and first one is servo object that allows us for configuration and controlling the servo motor. Next 3 are just definitions of the pins that we'll be using for the motor driver input and for controlling the servo. And the next 2 are a little bit more complex because they are our BLE characteristics. To create BLE characteristic object, we need to pass 2 arguments. First one is UUID, and second one are the properties of the characteristic. So in this case, read and write. We could also pass, for example, notify property. The UUID in here is defined in hexadecimal way. You could also use this code and just pass a UUID in string, but I think it's easier to search for shorter numbers rather than the long string, so we'll stick with the hexadecimal values. For now, we'll omit these three classes and come back to them later. Let's go to the setup function, and in here we initialize the serial connection for debugging purposes, just to print some messages in our code. Then we have definition of outputs for motor driver, and here we attach the servo pin to the servo object. That allows us for controlling the servo, just with one method actually. We could also specify some other parameters like servo.setPeriodHertz, specify the frequency of our servo, but for most cases you really do not need that, and the base default parameters are enough, so we'll stick to them. And then we go to the BLE functionality. First we need to initialize the device, and this name is the one that ESP will be advertising. So for example, when you go in your mobile phone to Bluetooth options, and you have there the list of all nearby Bluetooth devices, this name will show up there. Then we create a BLE server with create server function and set callback for this server. And what is a callback? It is actually, generally speaking, the function that is passed as a parameter to another function. But you can think of, for example, of an interrupt. When you define an interrupt, you define also a callback function, which is called when this interrupt occurs. So the same situation is in this case. We have a BLE server, and it can meet some events. For example, when we connect to the BLE server or when we disconnect. And when this event occurs, we can do something, put some logic there, and this is actually the callback. Well, I've said that callback is a function, but in this case we pass not a function, just a class. And this class is defined here. And as you can see, the only things that this class contains are two methods, onConnect and onDisconnect. And these are actually the functions that will be called when we connect to the device or disconnect. And how do I know these functions? Well, it is defined in the documentation, and as you can see, this class is inheriting from BLE server callbacks. And when we click Ctrl and left mouse button, we can go to the source, and as you can see, here we have all the virtual functions that we can override in our class and to make use of these events. In this case, we'll just use onConnect and onDisconnect just to show how this works. But you can also use some other functions, right? Okay, so let's go further. And now we create our BLE service. Because as we discussed, we need one service that will contain our two characteristics. And we do this with create service method, and then we pass just the UUID of the service, the same as we did in case of characteristics. Now we also set the callbacks, just not for the server, but for characteristics. And what we can find in these classes, in this case it's just an onWrite method, but we can view all the methods available for characteristic callbacks in this class. So BLE characteristic callbacks, we go here, and we have, for example, function that will be called when a read event occurs, or when we are using notification, so on notify, and so on. You can choose whatever you want and implement this in your class. And the only thing left was to explain how engine and servo are actually controlled. So let's go back to the callback classes. And in servo callback, we have retrieved the value of the characteristic that is written, and then we just pass it to the servo.write method. And this method is setting the servo motor to the specified position in degrees. But we don't need to map this value to anything, because even if it is invalid, for example, well, 500, this function will map it by itself. As you can see in here, in the source, if the value is greater than 180 degrees, it will set to the maximum. Okay, and when it comes to BLE engine callback, we also take the value from the characteristic, and this code is just really to test the engine. So when the value is less than 25, we turn off the engine. With analog write method, we write 0 to both inputs, and the engine is turned off. And when the value is greater, we set PWM value. But well, you don't need to really know how the PWM works behind the scenes. There are a lot of resources if you want to know more. I will probably make a video about this and link some resources in the description. But generally what you need to know is that you can control the speed of the engine by setting the value from 0 to 255 to the proper input. So when we set the half of this value, so for example 127, the engine will be rotating with half of its maximum speed. When we increase this value, we'll increase the rotational speed of the motor. When we decrease the rotation speed. And that's all you really need to know. And this function will map the more natural range for a human, so 0 to 100. So for example, when we write the 50 value to the characteristic, this function will map this to the 127, because it is in half of this PWM range, 0 to 255. And then we write this to the analog write method, to the input 1 by using the analog write method. And this way the engine is rotating half of its maximum speed. And one disclaimer here, because you could ask, why am I using analog write method in here? Well, I could just use digital write as I am setting the value to 0. But earlier I've encountered some problems when combining analog write method with digital write. And the reason for that can be that this analog write method is not the same as in Arduino IDE, actually in Arduino library. This is specifically designed for ESP32. As you can see in the source, this is the part of LEDC unit. And ESP32 has two units for controlling and generating PWM signals. One is the LEDC, as you can see here, and the second one is for controlling specifically the motors, different motors. And why am I using this unit to control the DC motor? Well, because it's much easier. As you can see, it is just this one method to control the motor, and with the second unit, which is much more robust, you have to set some more options and really know how it works behind the scenes. And I will probably make a video about this, but this is much more complex topic. And for controlling the simple DC motor, when you don't need any robust functionality, it is enough to use the LEDC part of the ESP32 library. Okay, so now we can go to the last of instructions in our code. So here we add the characteristics to our service. Then we start the service, and the last thing is to start advertising. So we get the advertising object from the server and call the start method. Now we just print some debug message that our BLE device is advertising. Okay, so as you can see in the application, we have Scanner tab where we can find all nearby Bluetooth devices. We have the Lego controller that we can connect to. This is our ESP32. And after the connection, we have all services that this device has. And we have unknown service, which we can see that the UID is the same as we set in the code. So this is our service, and we have two characteristics, one for the engine and one for the servo. And the bottom one is for the servo, I guess. So we can now set the value. We have to change the type to, for example, uint, because we have to set the integer value. And let's say, for example, 60. Now, as you can see, when I will send command, it moves. So it's working properly. Now we can test the engine. And in the engine, we have implemented the PWM. So we can also steer the speed of the motor. And when we, let's say, go to the 50%, because we are mapping this value to PWM values, so from 0 to 255. And now when I will send the 50%, the engine is moving, so that is great. But when I will send, let's say 100, it should move faster. Yes, and I'm not sure if you can see, but I am definitely feeling this. Okay, and now we can send the value 0 to stop the engine. Yeah, so our circuit works correctly. Now we can go to the assembly. And not to make this video last an hour, as I mentioned in the beginning, assembly part along with discussion about PCB versus universal board choice and 3D printing part will be uploaded as a separate video. Stay tuned!